You think you know what speed is. You think it's one of the cleanest ideas you have. Something almost beneath questioning. You point at a moving thing, you mark where it is, you wait, you mark again, and you divide distance over time. And you don't notice what you just assumed. Because hidden inside that innocent fraction are two objects you treat as unquestionable, a distance that stays put and a time that flows the same for everyone, a ruler that is really there, a clock that is really ticking, not your ruler and your clock, just the ruler and the clock. That picture works in your life because your life is small, your speeds are small, your distances are small, your timing errors are huge compared to the effects you're ignoring. So the world politely lets you pretend that measuring speed is just measuring a thing. But the moment you bring up the speed of light, you stop doing measurement and start doing metaphysics without realizing it. Because when you say the speed of light, you're not just saying light goes fast, you're saying there exists a speed that nature refuses to let you outrun. Not because of engineering, not because we haven't built a better engine, but because the word speed itself begins to break when you push it hard enough. And you can see it if you slow down and look at how you would measure c in the first place. You don't grab a photon like a baseball and track it. You set up an arrangement, a flash here, a detector there, you mark a distance between them, you mark a time on a clock, you divide, and immediately you're stuck with a question you usually don't have to face. Whose clock? You can try to be clever. Put the clock at the detector so you're not comparing two clocks. Fine, then your time is the moment the flash was emitted compared to the moment it was received, measured by one clock. But now you've smuggled in something else. You need to know when the flash was emitted according to the detector's clock, even though the detector is far away from the emitter. So you add a second clock at the emitter, then you say you'll synchronize them. That word synchronize is where your comfort ends, because synchronizing distant clocks is not a purely mechanical step. It is not like calibrating two thermometers in the same room. You have to send a signal, a physical signal, and you have to assume something about how that signal travels. Most people never notice the circularity to measure the speed of light. You want synchronized clocks. To synchronize clocks across space, you need a signal speed. And the cleanest signal you have, the one that doesn't depend on air or wires or muscle, is light. So you do what everyone does. You say, send a light pulse from a tube B, reflected back, and define synchronized to mean the trip out and the trip back take equal time. That definition feels harmless. It feels like common sense wearing lab gloves, but it is a choice, a convention. And once you admit that, even for a second, you should feel the floor loosen under you, because now the speed of light is tangled up with the way you decide what counts as at the same time in two different places. You thought c was a property of light. It is already becoming a property of your bookkeeping. Now notice something else you assumed without ever saying it. When you measure the speed of a car, you do not worry that the road's length might depend on the car. You do not worry that your seconds might depend on how fast the car is going relative to you. You don't worry because in everyday life, those worries would be ridiculous. But the speed of light is not an everyday speed. It is the speed that forces those worries to stop being ridiculous. Because c is where the naive idea of speed meets the fact that measurements are made by observers, by people carrying clocks and rulers, and those observers are not floating in a universal time bath. You can still insist at this stage that surely there must be a correct answer. Surely there is a real speed, what light is really doing out there, independent of anyone measuring it. That demand is the oldest instinct in physics, the instinct that the universe must come with its own preferred description, and our measurements are just attempts to approximate it. Hold on to that instinct. Don't let it go yet. Just notice that you're already relying on it to make speed feel objective. You're relying on it to believe that the fraction you compute is revealing something that exists without you. And now you can feel the tension that special relativity is going to exploit. You want speed to be objective, you want time to be shared, you want distance to be stable, and you want physics to not care about which constant velocity observer is really moving. Those desires cannot all coexist. Something will be taken from you. Not later. Not after the math. It starts here inside the definition of speed itself. You still have a fallback. Even after you admit that measuring c forces you to talk about synchronizing clocks, you can retreat to a simpler belief. Fine, synchronization is tricky, but once it's done, time itself is still universal. Clocks are just imperfect copies of it. This belief is the real target. Because special relativity doesn't begin by worshipping light. It begins by refusing to worship a hidden, preferred viewpoint. Einstein's first demand is calm and almost boring. The laws of physics should not change just because you're moving at a constant velocity. No secret frame. No cosmic rest. Just physics that looks the same to any inertial observer. Special relativity, but then comes the second demand, the one that feels like a technical detail until it ruins your intuition. The speed of light in vacuum is the same for all inertial observers. Is the speed of light everywhere the same? You've heard that sentence so many times you don't hear how violent it is. Because if you keep your everyday idea of time, one shared flow, one master clock, then that sentence is impossible. Think about what your brain automatically tries to do. You imagine standing still as a beam of light moves away from you at sea. Then you imagine running toward it. Common sense says your measured speed should be c plus your running speed. That's what happens with every other thing. That's what adding velocities means in your world. And relativity says this is wrong, not approximately wrong. Not wrong in extreme cases, just wrong in principle. So now you have a choice and you don't get to avoid it. Either you give up the idea that physics is the same for all inertial observers and you bring back a preferred frame, some hidden true rest, where light really behaves normally, or two, you keep the relativity principle and you let something else break. And the thing that breaks is not light. It's the shared clock. Here's the part nobody tells you in the clean classroom version. The constant speed of light is not an extra fact bolted onto Newton's universe. It's a statement that Newton's universe is not the stage. Because in Newton's picture, time is a background substance. The universe runs inside it. Events are stamped with a time label that every observer agrees on. Motion happens in time. In relativity, time is no longer that kind of thing. Time becomes something each inertial observer builds for themselves out of physical procedures, clocks, signals, definitions of now, and agreements about what counts as simultaneous. The moment you insist on keeping the laws of physics consistent, and you insist that light speed doesn't change from one inertial observer to another, you have already forced this outcome. You may still try to save your old picture by blaming measurement. You may say, maybe light speed is different for different observers, but their clocks distort in some conspiratorial way, so they all report the same number. That sounds like a rescue. It isn't, because their clocks distort compared to a master clock you can't access. A time that exists, but can never be operationally defined without already choosing a frame. That's not physics anymore. That's nostalgia. Relativity does something colder. It refuses to distinguish between real time and clock time when there is no experiment that can separate them. And this is where your intuition starts to feel personally attacked, because you don't merely believe in universal time, you live inside it. You plan your day assuming it. You coordinate with other people assuming it. You feel like now is a shared surface moving through the world. Relativity says that feeling is not evidence. It's a local habit. So imagine two observers in smooth, constant relative motion, no acceleration, no drama. Each carries a good clock. Each uses the same procedures. Each can insist with equal legitimacy that they are at rest and the other is moving. If time were shared, then their clock rates would have to be shared too. There would be a fact of the matter whose clock is actually slow, whose is actually fast. But relativity does not allow that fact to exist without smuggling in a preferred frame. The relativity principle removes the referee, so the only consistent option left is that the comparison itself is not absolute. Not because of bad equipment, not because you can't build better clocks, but because clock rate is not an observer-independent concept once you stop pretending there is an observer-independent time. This is the first real collapse. You realize you are using the word time in two different ways, one as an internal experience, one as a universal coordinate, and you assumed they were the same thing because your everyday world is too forgiving to expose the difference. Special relativity makes it explicit. The cost of keeping the laws of physics the same for all inertial observers, while keeping light speed invariant, is that there is no single clock that everyone shares. Special relativity, but we're still not done taking things away. Even if you accept that different observers have different time measurements, you might still cling to one last safety rail. Okay, maybe rates differ, but surely now is still objective. Surely simultaneity is still a fact. But some shades of that, you still believe in now. Not as a poetic idea, as a physical one. You believe that at any given moment the universe is sliced into a clean sheet, everything that is happening right now, and different people may be confused about it, but the sheet itself exists. Somewhere. This is wrong, not because humans are limited, not because signals take time, but because the question you're asking, which distant events are simultaneous, doesn't come with a single answer unless you first choose a rule for manufacturing one. And you already know the rule you've been using, even if you've never said it out loud. Here is the procedure, stripped down until it becomes uncomfortable. 2 places, A and B, 2 clocks, one at A, one at B. You want them to agree on now. So you send a flash of light from A to B, reflected back, and you decide calmly, confidently that the reflection event at B happened halfway between the send and the return as timed at A. In symbols, if the light leaves at T1 and returns at T2, you define the time at B to be T1 TT1, 222. Source: most people hear that and think, good, that's just measurement. It is a definition of simultaneity disguised as a measurement of it, because the definition quietly assumes something you cannot verify without already having synchronized clocks. That light takes the same time going from A to B as it does from B to A. That's what halfway means here. Source: you don't get to check the one-way speed of light without synchronized clocks, and you don't get synchronized clocks without a rule that effectively fixes the one-way speed of light. That loop is not a bug, it's the point. So when Einstein says you must make an assumption to compare times at different places, he's not being philosophical for fun. He's identifying the hidden seam in your picture of time. Source: now, to feel what this means, you don't need equations. You need a thought experiment that forces you to stop imagining now as a pre-existing layer. Imagine you're alone in deep space with a long, rigid-looking spacecraft. There's a lamp in the middle. There are detectors at the front and the back. You tell yourself a story you think is obviously true. When the lamp flashes, the light reaches the front and the back at the same time, because the distances are the same. That sentence contains your entire intuition of simultaneity. But the universe does not care about your sentence. It cares about procedures. If you are at rest with the ship, you can set up clocks along it using Einstein's light signal convention, and your clock network will declare yes, the arrivals are simultaneous. That will be your now slice for the ship. Source: now imagine a second observer drifting past the ship at constant velocity. That observer is not really moving in any privileged sense. They are inertial. They have just as much right to say they're at rest and you're the one sliding by. This is not politeness, it's the relativity principle. Special relativity, so they build their own clock network by their own legitimate procedures. And here's the quiet violence. Their synchronization produces a different now slice across the ship. The event they call light hits the front, and the event they call light hits the back are no longer paired as simultaneous. Not because the light behaved differently, not because they made a mistake, but because simultaneity at a distance is not a raw fact waiting to be read off the universe. It is an assignment that depends on how you lay time across space, and the Stanford Encyclopedia puts it bluntly in a way most textbooks avoid. Einstein indicated that whether two spatially separated events are simultaneous did not necessarily have a definite answer, but depends on adopting a convention for resolving it. Source: now, you might try to rescue yourself with a subtler intuition. Fine. Maybe different observers label simultaneity differently, but surely there's still a correct simultaneity underneath, and they're just using different coordinate systems. Rescue failed. There is no underlying operational test that picks out one distant simultaneity relation as the real one without smuggling in extra structure. Within special relativity, all you can directly access is causal order, what can influence what, and even that comes with a boundary. No causal influence outruns light in vacuum. The rest is bookkeeping. Source: this is why the speed of light starts to look less like a speed and more like a rule about the architecture of cause and effect. If you can't outrun light, then there isn't a universal way to declare distant events at the same time without first agreeing on a synchronization convention. Source: you thought now was a thing. It's a method, a protocol, a decision that becomes invisible only because you repeat it so reliably that it feels like reality itself. And once you see that, you can't unsee the next step. If simultaneity is constructed, then the speed of light is not merely describing how light moves. It is participating in how time is defined. You still picture c as a speed in the ordinary sense, a thing light has. A number you could, in principle, improve with better materials, better technology, better engineering, if only nature weren't so strict. That picture is not just incomplete, it aims in the wrong direction. Because the deeper fact is this: C is not primarily telling you what light does. It is telling you what space and time are allowed to mean. And the clue has been sitting in plain sight, disguised as a unit conversion. In the modern psi system, the numerical value of the speed of light in vacuum is defined to be exactly 299,792 or 458 meters per second, and the meter is defined in terms of how far light travels in a specified fraction of a second. Source, that seems like bureaucracy. It isn't. It's an accidental confession. You can treat C as a bridge between meters and seconds, because meters and seconds are not fundamentally separate kinds of stuff. You think a meter is a length, and a second is a time, and they live in different mental drawers. Relativity doesn't. Relativity treats them as two ways of measuring the same underlying thing, the interval between events, and C is the exchange rate. It's the number that tells you how many meters you should consider equivalent to 1 second when you're describing reality in a way that doesn't secretly privilege your human sense of time over your human sense of distance. If you don't like that, you can do something that physicists do all the time. You can choose units where C1, not because you're pretending light is slower, because you're admitting something you usually refuse to admit. Meters and seconds were never absolute categories. They were bookkeeping choices. Once you set C1, a second and 29,99792,458 meters become the same kind of interval described in two dialects. This is the moment where your intuition usually panics and tries to reattach itself to light. It says, okay, but surely this is still about light rays and electromagnetism and photons. No. Even if you never mention light again, you can't escape the invariant speed. You will re-encounter C as the slope of the boundary between what can influence what and what cannot. You will re-encounter it as the thing that keeps causal order consistent when different inertial observers disagree about simultaneity. Light is just how nature lets you see the structure. It's the most convenient messenger, but the structure is not about the messenger. So what is C, really, if it isn't how fast light goes? It is the statement that space and time are not separate stages. They are one stage, stitched together, and the stitching has a fixed tightness. You can feel this without equations if you stop thinking of motion as an object moving through space and start thinking of physics as events related to other events. An emitter flashes, a detector clicks, two events. You can separate them by distance, by time, by both. In Newton's world, these separations are independent ingredients. Time can be whatever, space can be whatever, and you can keep them conceptually apart. In relativity, you don't get that freedom. If you push one, the other responds. Change the time assignment by switching inertial frames, and the distance assignment changes with it. The relationship isn't a detail, it's the backbone. That backbone has a signature number, C, and now you see why the phrase "the speed of light is constant" is such a trap. It makes you think a particular phenomenon is being protected. What's being protected is something colder, the consistency of space-time itself. Once you internalize C as a conversion factor between time-like and space-like descriptions of the same interval, a new discomfort appears. If C is the exchange rate between meters and seconds, then the weird effects you've heard about time dilation, length contraction aren't things that happen to objects. They are what happens to your measurements when you insist on keeping the exchange rate fixed while changing your state of motion. And that means the next intuition to destroy is the one you probably still have tucked away as a safety story. That stuff is just distortions. Reality is normal underneath. No. Those distortions are the price of consistency. You've heard the slogans. Moving clocks run slow. Moving objects get shorter. You think these are weird effects that happen to things when they move fast, like drag or heating or strain. You think the universe is basically normal, and then high speed adds a layer of distortion on top. This is wrong. Time dilation and length contraction are not physical ailments that appear at high velocity. They are what measurement becomes once you accept the previous chapters. No shared clock, no shared now, and a fixed conversion factor between space and time that cannot be negotiated. So let's do this with a procedure, not with math. Imagine you build a clock that doesn't use gears. No springs, no electronics, just pure geometry. A light clock, two mirrors facing each other. A pulse of light bouncing between them. Each bounce is a tick. It's almost insulting how simple this is. It's also merciless, because the definition of the meter in modern standards quietly elevates light's motion into the definition of length itself. The meter is defined via the distance light travels in vacuum in a specified fraction of a second nist. So a light clock is not a cute trick. It's timekeeping built out of the same relationship that pins down our units. Now set the clock on a table next to you. You watch the light bounce straight up and down between the mirrors. Tick, tick, Then put the same clock on a spacecraft that slides past you at constant speed. You still know what you'll see, because you can't stop your brain from drawing the picture. The clock is moving sideways while the light bounces up and down, so the light must travel along a diagonal path between mirrors, longer than the straight up and down path, longer path per tick. But here's the part you don't get to negotiate. In your frame, the light still moves at c, not approximately, not as long as it's convenient. The invariant speed is the constraint, special relativity, so if the light has to travel a longer distance between ticks and it still travels at c, then the time between ticks in your frame must be larger. The moving clock ticks slower. Not because the clock is malfunctioning, because you forced a geometric fact, the world line of the light is longer in your description, and the speed constraint prevents you from saving the old timing. This is the first half of the trade. Now, the second half arrives, and it arrives the same way, through simultaneity. You don't measure the length of a moving object by admiring it. You measure it by marking the positions of its endpoints at the same time, same now. A single slice across space. But Chapter 3 already took that from you. Same time, across distance, is not an observer-independent fact. It depends on your synchronization convention and your inertial frame. Conventionality of simultaneity SEP, so when you say, the ship is 10 meters long, what you really mean is, in my frame, using my definition of simultaneity, the front and back endpoints occupy positions that differ by 10 meters on my chosen now slice. A different inertial observer uses a different now slice. Not because they're confused, because they are building time across space differently, consistently. And once you accept that, the contraction stops being mysterious. It becomes inevitable. If the moving ship's clock is ticking slower in your frame, then the ship's internal rhythm, anything that happens in the ship's time, is spread out in your description. To keep the invariant speed structure consistent across frames, your now slice intersects the ship's world tube at a different angle than the ship's own now slice does. That intersection is what you call its length. Different angle, different length. If you want a mental picture for this, stop picturing a ship as an object occupying space. Picture it as a history in space-time. A tube made of events, with the front and the back as two edges of that tube. A length measurement is not reading off a static thing, it's slicing the tube with your plane of simultaneity. Different observers slice the same tube differently, so they disagree. And neither is privileged. This is why space-time diagrams are not optional decoration. They are the cleanest way to see that time dilation and length contraction are the same phenomenon seen from different cuts. If you want visuals while drafting the video, these are representative references. A light cone Minkowski diagram image source Wikipedia, light cone from the image search results, a basic Minkowski diagram explainer page Brown Math, Minkowski diagrams from the image search results, a length. Contraction spacetime diagram animation source Wikimedia Commons, animated spacetime diagram length contraction from the image search results. But don't use those diagrams yet as a crutch. Feel the logic. You wanted a universe with no preferred inertial frame, a consistent causal structure, and a fixed invariant speed. You got it. And the price is this. Space and time become negotiable currencies. You can trade one for the other depending on motion, but you cannot change the exchange rate. That exchange rate is C. So the next time you hear moving clocks run slow, stop treating it as an effect on clocks. The clocks are not the story. The story is that your old idea of duration and distance as separate absolute categories is no longer available. Now there's only one thing left to attack. The belief that all of this weirdness is merely about measurement, not about cause and effect. Because once you understand the trade, you can see the real function of the light speed limit. It isn't there to stop you from going fast. It's there to stop you from breaking causality. You've tolerated the weirdness so far because you've been telling yourself a comforting story. This is just about measurement, just about perspective. Nothing truly breaks. Reality stays intact. We just describe it differently. Because the speed of light limit is not mainly a statement about engines. It is a statement about cause and effect. And if you allow faster than light messages, you don't just get faster communication. You get a world where the order of events is no longer stable, logically unstable. Here is the key point you usually don't sit with long enough. Different inertial observers do not merely disagree about how long something took. They disagree about which events are simultaneous, and for certain spacetime separations, they can disagree about which event happened first. You can pretend that's harmless as long as you restrict yourself to events that cannot possibly influence each other. Random flashes. Fine. But the moment you talk about signals, information, triggers, causes, you are no longer allowed to shrug. Because cause comes before effect is not a taste. It's the minimum condition for doing physics without contradictions. Now imagine, calmly, that you have built a device that sends a message faster than light. Nothing else changes. You keep special relativity symmetry between inertial observers. You keep the same physics for everyone moving uniformly. You just add one new capability, a superluminal signal. You think you've added a shortcut. What you've actually added is a way to draw a causal arrow that can tilt outside the light cone. And once you do that, special relativity does something you won't like. It shows you that faster than light in one frame can become backwards in time in another frame. This is not a metaphor, it's the geometry. The classic demonstration is the tachyonic anti-telephone, a thought experiment showing how faster than light signaling between two observers in relative motion can be arranged so that a reply arrives before the original message was sent. You just need to accept two facts you already accepted earlier. Different observers slice space-time into now differently. You are refusing a preferred frame. So if observer A can send an FTL message to observer B, there exists some range of motions where in B's frame, the reception event can sit earlier than intended, because B's definition of simultaneity is tilted relative to A's. The signal is space-like, its time order is not invariant. Now add the second step, the part that completes the paradox. B sends an FTL reply back. In A's frame, the reply can arrive before A sent the original. So it can receive a warning that prevents them from sending the message that caused the warning. That is not time travel as entertainment. It is a broken dependency graph, a contradiction you can engineer with nothing but uniform motion and a willingness to let information outrun light. That is why physicists often summarize the light speed limit with a sentence that sounds philosophical but is actually operational. The speed of light is the speed at which causal influence can propagate in special relativity. Because the boundary defined by C separates what can be consistently cause and effect from what cannot. If you want a visual anchor for this chapter while you storyboard, use a light cone diagram. Events inside the cone can be causally connected. Events outside cannot without superluminal influence. Source, and if you want a clean pedagogical page of Minkowski diagram intuition, this one is serviceable. Minkowski diagrams, Brown Math. Source, you might try one more escape route. Okay, but maybe you can go faster than light without sending information. People often say that because it feels like a loophole. But notice what you're admitting. The thing you're actually protecting is not light. It's not even the number C, it's the integrity of causal order. You're admitting the real role of C in the theory. It is the edge of the region where before and after remain consistent across all inertial frames. So the speed of light starts to look less like a speed limit and more like a statement about what kind of universe you live in. A universe where too fast doesn't just break machines. It breaks logic. And once you accept that, the final intuition collapses on its own. The desire for an external background in which all this is happening an absolute stage where events are simply ordered and we're merely confused about them. Relativity doesn't end by giving you a better stage. It ends by removing the stage. You want a final anchor. After everything you've had to give up, shared clocks, shared now, intuitive speed, you still want to believe there is a deeper layer where the universe is simple, and relativity is just a complicated way of describing it. A hidden stage behind the stage. A master timeline where events are ordered the right way and all observers are merely reporting partial, distorted views. This is wrong, not as an opinion. As a demand that the theory has no room to satisfy. Because, once you accept what C is actually doing, you see what it has been quietly removing from the beginning, the idea that reality needs an external bookkeeping system. You wanted time to be an invisible ruler, the universe slides along. But you already watched that ruler fracture. Each inertial observer builds time by procedures, by synchronization rules, by clocks, by definitions of simultaneity that cannot be made universal without choosing a preferred frame. And the moment you refuse a preferred frame, you refuse a universal time. Conventionality of simultaneity SEP. Then you want a distance to be the safer object, the thing left standing when time became suspicious. But distance too. turned out to be a measurement that depends on how you slice now across space. Change the slice, change the length, not because matter compresses out of fear, but because length was never a raw fact independent of how you coordinate events. So you turn back towards C, and you try to place it where a normal speed belongs, inside the world, like a property of a thing, like a number you could have discovered and written down. And the universe gives you a humiliating hint. In our measurement system, we define the meter using light. The meter is the path length light travels in vacuum, in 1299/12,458 of a second. NIST meter that looks like a human convention. It is, but it mirrors a deeper truth. It only works so cleanly because C behaves as an invariant conversion factor between space and time. So here's the uncomfortable reframing. The speed of light is not just how fast something can go. It is the statement that reality comes with a built-in boundary between what can be linked by cause and effect and what cannot, without destroying the notion of cause and effect itself. Tachyonic anti-telephone. If you want a visual way to hold that boundary in your mind, don't picture light rays as glowing streaks. Picture a geometry, a light cone. Inside it, causal influence is possible. Outside it, the order of events is not even stable across inertial frames. Light cone, the geometry is not drawn on spacetime. It is spacetime rulebook. And this is the point where the title becomes slightly misleading in a productive way. Because what nobody tells you about the speed of light is that at the deepest level we're discussing here, C isn't a speed limit sign placed somewhere out in the cosmos. It's more like the unit conversion stamped into reality's ledger, a fixed rate at which time separation can be traded for space separation when you switch inertial frames while keeping the causal structure intact. That's why you can set CC1 in natural units and nothing physical changes. You haven't changed light. You've admitted that meters and seconds were never fundamentally separate currencies. They were two ways of counting intervals. The exchange rate was always there. Now notice what this does to your original mental picture. You thought the universe had objects moving around in a container called space, while a river called time flowed uniformly in the background. Relativity does not replace that picture with a better container. It replaces it with something colder. Events related to events, stitched together by what can influence what, with space and time emerging as observer-dependent projections of a deeper invariant structure. If you still demand an absolute what really happened first, you're demanding that the universe pick a privileged slicing of reality into moments, and special relativity refuses. Not because it likes being difficult. Because, once you accept the relativity principle and an invariant causal speed, there is no experiment inside the universe that can reveal such a slicing without contradiction or circularity. So the philosophical ending is not a comforting one, it's an austerity. Reality does not appear to come with an external clock. Reality does not appear to need one. The speed of light, this number you thought belonged to light, ends up being the quiet signature that the universe is self-contained. It measures itself from within. It permits certain connections and forbids others. It gives you structure without giving you a global now. And if that makes you feel slightly ungrounded, that is the correct reaction. Because the final intuition to lose is the belief that the universe owes you a background. It only owes you consistency.